Good morning, everyone. How did the homework go, as usual? If you had any,
I've not bed early because
if you had any issue with the homework, please get going. Okay, 97. Any other questions? All right. So all right, so we start with those. So I start with number 23. Here we are. Alrighty. Number 23, we have to find the derivative of the following function. Y equal tangent 5x squared. Okay. So both of those problems fit into the picture of inside outside. So the first step we have to do is we pick our outside function. That's the first step, and then the inside. And the outside is the last operation you do when you want to evaluate an expression like y equal tangent 5x squared. So what is the outside? I'm gonna call it u, f of u, and u is the inside. So what's the outside function in this scenario? Quickly. Okay, I'm listening to you. Okay, so the outside is the tangent function. So we're gonna write here tangent u. And the inside it's basically what's left. So what is the derivative? What the chain rule tells me? So this function is actually the composition. It's f of g of x. That's really what my function is. So g of x is 5x squared, and then you take its tangent. So y prime is the derivative of the outside evaluated at the inside function. You'd multiply it by the derivative of the inside. So now we have to compute each one of them. What's the derivative of the outside function? Basically, what's the derivative of the tangent? And those are, we have to memorize. Derivative of the tangent is the secant. So it's going to be equal. The derivative of the outside, it means the derivative of the tangent. But instead of u, we put the inside function. And we multiplied this by the derivative of g prime. And now we're done, basically. So almost done. So it's secant squared. Don't never forget the parentheses or it will be very confusing. Times, so the chain rule, multiply two derivatives times the 10x. Okay. So let's look at your other problem. I try to go in order. And number 25. Okay. So here they give us a table. And they give us the function h of x, which is f of g. So, and another function, they call it p, which is g of f. So of course it is, those functions are different. Here the outside is f, the inside is g. Here the outside is g, the inside is f. And they give us a table of values, and they want us to ask the following: h prime of 3, and they want us to find h prime of 2. Or sorry, h prime of 5. No, your question is D. And they want us to find p prime of 2. And they are all the same. Once I do two of them, the picture will be clear. All right, so what is h prime? To find the derivative at a point, first we find the derivative at any x. After we find the derivative for every x, then I plug in what happened at the point. So what is h prime of x? So always you find it for any x. For any x, here we're going to use the chain rule verbatim. It tells me it's f prime at g times g prime. That's what the chain rule tells me. So for any x, that's what we computed. Now I want to zoom in at a particular value of x. So it's equal to what? Now I plug in 3 for x across the board. So it's f prime of g of 3 times g prime of 3. That's the setup. Now we go to our table and we pick up the value. So it's equal to. So I'm using the table I have for the value. So to be able to find h prime, I need two things. I need g prime and I need g of 3. And actually I need something else. So let us see what we have. According to the table, g prime of 3, so it's f prime at g of 3. According to the table, the g of 3 is 1. So this is 1 according to my table. G prime of 3, according to the table, is equal to 20. But we're not done yet. I need f prime at 1 because that's g of 3. Back to the table. F prime at 1, according to the table, is equal to 5. 5 times 20, which is 100. Okay, so those are nice problems. We don't have numbers involved, but actually it's helping us to understand. Okay, now we're going to we'll do the same for P, and let's do that. So that's P of x, and I'll use verbatim the chain rule. That's the composition. So P prime of x now, the outside is G. So it's G prime evaluated at f of x multiplied by the derivative of the inside, which is f prime in this case. So that's the rule. Now they want me to find it at 5. So, sorry, at 2. So now once I find it for any x, I zoom in at 2 and I say, okay, what's P prime at 2? So now I plug in 2 for x across the board. So it's G prime of f of 2 multiplied by f prime of 2. Okay, so this is equal to. Now I pick up the values from the table. But here I have G prime of f of 2. So first I need f of 2 and then I need the G prime of it. So it's G prime of. Now the table tells me that the function f at 2 takes the value 3 times f prime at 2. The table tells me that at 2 the derivative takes the value 2. Okay. So that's from the table. And f at 2, yeah. Finally, I need that. What's G prime of 3? So the function, I have to go back to the table. And at 3, G prime takes the value 20 times 2, giving us a 40. Okay, so we just follow the rule. The main thing is really to have this form under our belt. Once we have it, we can actually do a lot of problems. All right, let's do your other problems because this section is mainly about the chain rule. Had no idea, no plan to introduce any new things today, but just work with the chain rule. So let us look at number 41. Okay, so here we have a function to the power 5. Sorry, no, that's not 41. So 41 is y equal to the fourth root of 2x over 4x minus 3. okay? And I need to find the derivative of this function. So what would you do if you were me? What would be your first step? What would be your first step? Rewrite. Very good. How do you rewrite it? So first step, absolutely rewrite it. The fourth root is to the power of fourth. And then this is 2x over 4x minus 3. Because we have to rewrite, because as I said, derivative don't like those roots. We need the fractional exponent. And now we have the inside function. So this will basically give everything away. So my f of u in this case, and my g of x. So now what's my inside function? My inside function, sorry, my outside. We start with the outside. The outside is the last operation we do. The last operation we do is we take whatever I have here to the power fourth. So that's the last operation we do. The inside is everything left. So this is the 2x over 4x minus 3. Now the rest is putting together. There is nothing left into the problem. So y prime is the derivative of the outside, but evaluated at the function g, we time it with g. So this is equal to, what is f prime? So this is f, it's u to the power of fourth. So f prime is 1 over 4, your u to the power of 4 minus 1, times g prime, it means times this. And what should go here in this parenthesis that I left open? What should go in this parenthesis? What go into parenthesis is, finish my sentence, what should I put here?
Same as the other parenthesis.
Which means, what did I call that?
Oh, the g function.
Right, the g function. We put the g function, okay? Or we can go here and you can find the f prime of u, but we know what we're doing. We're finding the derivative of the function that take an expression to the power 1 over 4, which is this one. And now this is easy because this is nothing more than if fourth minus 1 is minus 3/4. So there is nothing here, is fraction. Now here it's also easy, but I have to use the quotient rule. So let us use the quotient rule. Okay, what does the quotient rule tell me? It's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. For derivative of 4x minus 3, it's a 4, divided by 4x minus 3 to the power 2. And now I just simplify the whole expression and I am done. So, okay, so finally it's going to give me, I will keep this in front so you guys can write and I can read. So y prime equal 1 over 4, this expression to the minus 3/4 times. Okay, here what will I get? 8x minus 8x, they simplify. 2 times minus 3, that's a minus 6 over 4x minus 3 squared. Now the rest, we can kind of let it look a little bit nicer. Minus 6 over 4 will give me minus 3/2. This you can keep it the way it is. And this is 1 over 4x minus 3 squared. And of the problem. Please ask question as we go on. Yes.
Do we have to multiply the negative 6 with 1 over 4th?
I think you should, because you're a calculus student.
All right.
As simple as that. What?
Okay.
Yeah,
Sounds good.
I mean, you guys are
Negative.
going to be dealing with a lot of hard, computation. So that's, you are engineers and math. So this is your science major. So this is, yes, I would want you to. All right. So let us look at 75. Oh. What is 75? Oh, all right. So we have a function y, and it's the square root of f of x, okay? And the question is, find a formula for its derivative. Okay. So, how can I find the formula for the derivative here? What will be your first step? Always.
Rewrite.
Rewrite. I'm glad you guys got that under your belt. That's rewrite. Okay. All right. So now here, when I rewrite it, what's going to be your inside function? Sorry, we start with the outside. What is your outside? And what is your inside? Okay, what is your outside function here? Don't be afraid.
U to the power 1/2.
Right, it's u to the power 1/2. That's the last operation you will do. But this time I cannot write it f of u because it doesn't, I have f in here. I can call it, I don't know, I can call it h of u if you want. That's u to the half. That's the outside function. What's my inside function in this case? Quickly. My inside here. Absolutely, f of x is my inside. F of x is my inside. With this setup, my y is h of f of x. So with the setup, it's h of f of x. So you take f of x, and then you take its square root. Now, the derivative, it's h prime at f times f prime. Okay. Now, every piece by itself. What is h prime? What is h? Is u to the half. What is the derivative of u to the half? It's a half. So the derivative of u to the half is a half u to the half minus 1. So now that's u to the half minus 1. Right here, it is the f of x function times f prime. Now we have to keep f prime because, we don't know it. The idea is to express the derivative in terms of f prime. So finally, I can rewrite this as f of x to the minus a half. So f of x to the minus a half is basically 1 over the square root of f of x. So this will give me 1 over 2 times the square root of f times f prime. Now, slowly, not yet. We're gonna probably start being able not to do this step, but not yet. Even for tomorrow, I want this step to be done. All right? So those are nice problems because it helps us slowly understand how the chain rule is gonna work. We don't know why it works, but that's okay. We know at least how it works. Now I look at 85 and then 97. So 85, where is it? So back to finding the slope because we never leave track. We never should forget that the derivative represents the slope of the tangent line. So we have the function f of x equal x times e to the 2x. And the question is, find the value of x for which the slope is 0. Okay, so we have to find the value of x where the slope of the tangent line is 0. Or basically when the tangent line is horizontal. Usually I don't really tell you slope is 0. I put the slope is horizontal. So it means that we have to set the derivative equal to 0 and solve for x. Now to do that, we have to find f prime first. So we have to find f prime. Okay. How shall we start finding f prime? So when I look at f now, what do I see first? It means, do I see a chain rule? Do I see a product? Do I see a quotient? What do I see when I see f prime? Product. It's x times e to the dx. So I see immediately a product. So to find its derivative, I need to apply product rule. So that's the first step in the process. Product rule. So what is f prime? It's the derivative of x times e to the 2x plus x times the derivative of e to the 2x. Okay. Now each one by itself separately, and then we proceed. So this will be equal to derivative of x is 1 times e to the 2x plus x times, and here it's e to the 2x. How can I find the derivative of e to the 2x? Is this a chain rule problem? A simple chain rule problem. What is my insight? So this is, I don't have x here. I have 2x. So that's right there. We need a chain rule problem. So first a product and the chain rule. Now what's the derivative of e to the 2x? Now we can go to the side, usually on the board. I would always, if I had a big board, I always do that. So I move to the side and then I focus on e to the 2x and I find its derivative. So again here, the outside will be e to the u and the inside is the 2x. So I totally isolate this little piece. So the derivative is, let me call this f of u, is f prime at u times, sorry, my apologies. It's f prime at g of x, my inside function, times g prime. So it's equal to the derivative of f is e to the u. Its derivative is e to the u, but I evaluate it at g. So instead of putting q, I have to put the g times the derivative of that. So which will give me e to the 2x times 2, which is 2 times e to the 2x. Okay, so we move to the side for the little pieces. And now I have, this is times 2 e to 2x. So now I found f prime. Now I need to set this equal to 0 and solve for x. All right, so I'm going to set this expression, and this will become 2x e to the 2x equal to 0. Okay. And I solve. How would I solve?
Factor out e to the 2x.
Absolutely. We have to factor out. As I said, solving is really factoring. Once you set equal to 0, you factor. So now I will have e to the 2x, 1 plus 2x equal to 0. Now, if a product is 0, it means one of the factor is 0. This factor is always not 0, because the exponential is not 0. So the only way this product can be 0 is by having 1 plus 2x equal to 0, which will give me x equal minus a half. So the slope is horizontal at x equal minus a half. All right. Now the second question is, explain the meaning of your answer to part A in terms of the graph of f. So x equal minus a half in terms of the graph of f. What does this represent? In terms of the graph, what do you expect, at least for now, to happen at x equal minus a half? So if I'm graphing this function, so that's x e to the 2x. That's the graph of this function. And this is x to e minus a half. First, let's look at the point. If x is minus a half, the function is minus a half e to the minus a half t to the minus 1. So that's the output. So the output, so this is the value of the function at minus a half. That's not the derivative now. So this is minus a half minus 1 over 2e. So at this point, minus a half here. That's the point on the graph. What do you expect to happen at this point? If the derivative is 0, what do you expect happen at this point? The slope is 0. It means right here, the tangent line is horizontal. So how the graph would look like? It means right here, the graph basically doesn't change much. So it's like flatten out a little bit. Right here, the graph will flatten out. So how could it almost flat? Because there is the derivative is, so it's going to be look either like that, and that's the part I don't know yet. So it's going to be concave up if you want, or concave down, and this is something we will see. And there is a third scenario. We will talk about it when we hit the subject. But that's really what we expect. The function is basically going to somehow flatten here because the slope is 0. So it's going to almost look like a horizontal line. That's how the function would look like. It means near this point, if I zoom in, the function is almost horizontal. So we can actually graph it. We can use Desmos to graph it. And we zoom in at this point, you realize that the function is a line, horizontal line. It means barely changes its value. The changes is very, very small around this. Right? So I guess I'm almost done, which is actually good problems. And I still have 97. Okay. So we'll look at number 97. Okay. So, okay, let me pick that up, sorry. 97 is the following. 97, composition of function. Okay, so here I have a function f, and they're giving me a bunch of info about the function. So they are telling me that at 0, the function takes the value -3. At 1, the function takes the value 3. And the derivative at 0 is 3. Oh, they gave me a lot of value. And they gave me f prime of 1 equal to 5. Okay. And then they created a function. They called it g of x. And g of x is the sine of pi times f of x. So what's inside the sine? What's inside the sine is pi times f of x. And here's the question. The question is evaluate. So we need to evaluate the g prime at 0 and g prime at 1. Very good. So, okay. All right, how would you want me to do this? I'm looking at the chat, I'm listening. Well, how would we do that? So I created a new function called g, which is kind of weird. So first, before we do that, let us understand like what they are talking about. I mean, well, how is this defined? Let me see. Let me take another piece of paper here. Suppose f of x is equal to x. Okay, just understand this notation. What is g of x? Okay, just want you to understand this notation. Suppose f of x is x. G of x is what? What did I mean by g? It's the sine of what? Sine of pi x. That's the function g. That's how g obtained. If f of x equal whatever, x to the power 3, that's what I mean. What's g of x? I'm trying to understand what does this notation mean. That's a new function. It's the sine of pi times x cubed. That's what they mean by, so whatever f is, the sine, the g is sine of pi times x. If x is x, that's my g. If x is cubed, that's my g. That's really what the g is. Okay, so now we want to find the g prime at 0, and Elizabeth is telling me use the chain rule. All right, I'm going to use the chain rule. So we're going to use the chain rule. So we need to find, first we find g prime for any x, as I said, and then we zoom in at 0. Okay, so g prime of x, and I need to write it as a composition. So g is the sine of pi of f, pi times f. Okay, so what is the inside? I meant, what's the outside? And what's the inside? Okay, what's the outside in this scenario? Okay, Austin tells me sine of u, absolutely correct, but I cannot write it f, I'm gonna call it h of u because f is being used. So the outside is the sine. And the inside, there is nothing left. The inside is, what's inside? So the inside is pi times, so that's the inside, I can call this pi times f of x. Okay. And now verbatim the chain rule. So by rewriting it this way, my function g become h of, see if I call this g of x, h of g of x. That will be my function. So my derivative is, okay, that's the sine, the derivative of the outside. So it's the derivative of the outside evaluated at the inside times the derivative of the inside. Now what's the derivative of the outside? The outside is the sine. The derivative of the sine is the cosine. So the derivative of that is the cosine. But we evaluated at the inside times. What's the derivative of pi times that? Now, pi is a constant. So we have a constant times a function. So its derivative is pi times f prime of x. That's where this one goes. Okay, so now I have a formula for g prime as a whole. Now I want to zoom in. I want g prime at 0. At this stage, I plug in 0 for x across the board. So it will become cosine of pi times f of 0. Because no matter what x is, that's g prime. So at 0, I multiply it by pi times f prime at 0. At this stage, I pick up the value they gave me and I move on. So this is the cosine of pi times. According to the book, at 0, f takes the value minus 3. So that's really from what's given to us. I have that. Times pi is a constant. Times f prime at 0, according to the book, f prime at 0 is 3. So phi is equal to the cosine of minus 3 pi times pi times 3. And now the rest we computed. Now cosine minus 3 pi. What's the cosine of minus 3 pi? Anybody? It's absolutely -1. You can go on your unit circle if you want. What is minus 3 pi? That's minus pi, minus 2 pi, minus 3 pi, we write here. And the cosine is the x coordinate. So this is a -1 times 3 pi, which is minus 3 pi. And of the problem, okay?
If you're taking a derivative of pi, which is a constant, why wouldn't it be 0?
Okay, I'm glad you asked this question. Okay, I'm gonna follow you verbatim, all right? Okay, so let's see, what does the product rule tells us? You tell me.
The derivative of of x times, or the derivative of f times g times, or plus the g of prime of, or g prime times f of x.
Absolutely correct. Now I'm gonna apply this to pi times f of x, okay? Now I'm gonna look at this as what? As the product of pi times f of x. Are you with me?
Yeah.
Okay, start thinking. What should you get? Derivative of pi times f plus what?
Plus pi times derivative of f.
Absolutely, don't be afraid. Because that's the product of two functions, you're right. One is the pi function, which is a constant function, and the other is f. So what this would give me? It's a very good question because a lot of students have issue with that. What's this will give me? What's the derivative of pi?
Pi or 0, you said it should.
0. Why it is 0?
Because it's a number, so any derivative of a number is 0.
Or a constant. I don't like
a
constant because it's not derivative of a number, it's derivative of a constant. Because I'm thinking of pi right now as the function that takes the value pi for all x. It's crucial. That's how I'm thinking about it, okay? So that's a 0.
Okay.
Plus pi times f prime of x. Okay? So even if you use the product rule, you will get pi times f prime.
Okay, that makes sense now.
Right? Now, so for that, sometimes to avoid having to really do all this, there is a formula that tells us if you take a function and you multiply it by a constant, it's equal always to the constant. So you can basically get the constant out times the derivative of the function.
Okay.
So you can use either way. Okay. All right. So we did a lot of nice problems. Some of them are problems that I wanted actually to make sure you get them, and some you guys ask. Now, there are two ideas I want to talk about. It's the chain rule. As I said, I'm not going to change topic today at all. Tomorrow I'll change it, but not today. Sometimes there are problems, especially when the quotient rule is involved, that could be done in two ways, using the chain rule and using the quotient rule. And usually our choice should be, we look at the function and we see which way is easier. So let me see what I'm talking about. I will take the following function. Suppose I take f of x to be equal to, or y equal 1 over 2x plus 3 to the power 2. Okay, and the question is, find the derivative. That's what we are doing now. Okay. So how can I find the derivative of this function? All right. We will find it in two ways. First, if I look at it, you know, that's a quotient. This divided by that. So I will look at it. I will use the quotient rule. Verbatim. What does the quotient rule tell me? Equal to, here, the derivative of the numerator. Derivative of the numerator times the denominator minus the numerator, which is 1, times the derivative of the denominator. So the derivative of all this expression divided by the denominator, the whole thing is squared. Okay. This is equal to what? 1 is a constant. So the derivative of 1 is 0. So this whole thing, 0 times anything is 0. So this piece is 0. Minus the derivative of 2x plus 3 to the power 2. That's a small chain rule problem because I have a function to a power. So we can a little bit isolate this and treat it as by itself. So I isolate it and I look at it as a chain rule problem. So my inside here, the outside is u squared, that's the outside. And the inside is 2x plus 3. So the derivative is going to be the derivative of the outside, which is 2u, but we evaluate it at the inside, times the derivative of the inside. So the derivative here should be 2 times 2x plus 3. So that's the derivative of the outside evaluated at the inside. So that's the piece that's picking up the derivative of the outside at the inside. We're going to times this by the derivative of the inside. So the chain rule, this piece is the outside at the inside. And this piece, derivative of the inside. So that's how, divided by. Now, 2x plus 3 squared will give me 2x plus 3 to the power 4. And now we are almost done actually. The 0 is 0. I will have minus 2 times 2x plus 3. Derivative of 2x plus 3 is 2 over that to the power 4. Okay? And it's going to be equal to minus 2, that's a minus 4. And that's 2x plus 3 here, and here 2x plus 3 to the power 4. This could be done. We can simplify, and this will leave me with that. So that's one way to do the problem. Use the quotient. It's not hard, I mean, definitely, but we use the quotient rule. Now I'm going to do this same problem, but basically by rewriting it in a different way. So another way to do this problem. By rewriting it as a product first. I'm listening.
How'd you go from 2x plus 3 to the power 4 to 2x plus 3 to the power 3?
Yeah. Suppose I have a over a to the power 4. Okay? This gives me what? It's a over. What's a to the power 4? Okay? So basically, I simplify my a. Leave me with that. Are you with me?
Yes. Okay, I get it now. All right. Thank you.
It's
What about
basic.
this? What about the squared? Isn't it supposed to be the inside of it squared? Like the, what was it? The bottom's already squared, and then we're squaring it again. Shouldn't it be? Never mind. I'm thinking of something else.
It's 2 times 2. You multiply the power.
Okay, yeah, I got that.
Okay. All right. Now, the other one, we're going to rewrite f as a product. We rewrite f as product. What do I mean by that? Quote unquote. Okay, so the other approach, which is a lot of time useful, it depends on the function. I'm going to rewrite it in the following format. I'm going to rewrite it as, basically, I'm going to lift this to the numerator. What this will become? 2x plus 3 to which power? To the power minus 2. Okay, so we're going to rewrite it, and then I'm going to use the chain rule. So first, I'm going to rewrite it to x plus 3 to the power minus 2, and now I'm going to use the chain rule. And this is sometimes very useful for computing some derivative, and I definitely want you to do that sometimes. So now, here, the inside, the outside, and the inside. So the outside here will become, this is the outside. So the outside is u to the minus 2. I'm going to call it h of u because f is being used. It's u to the minus 2. And the inside is 2x plus 3. Okay, so now this is mine. So the outside is the operation of taking an expression to the minus 2. The inside is the expression here. And now finally, I need to find the f prime. So now what is the f prime? It's the derivative of the outside. Now what's the derivative of the outside? We can do it quickly. It's minus 2 times the u, which is the 2x plus 3, to the power minus 2 minus 1, which is minus 3, times the derivative of 2x plus 3, which is equal to minus 2, 2x plus 3 to the minus 3, the derivative of 2x plus 3 is 2, which basically minus 4, 2x plus 3 to the minus 3. And this will give me, this is the same as this over 2x plus 3 to the power 3. Okay, so the idea here is to rewrite it as 2x plus to the minus 2 and then use the chain rule. Of course, we get the same answer. Of course, that's the slope. There is one slope to a function. But this is a bit easier in this particular problem. In this particular problem, it is easier. Okay. So some of the problems I may assign, I will see. I will put on bright space everything for tomorrow. Now the last idea is how there is another way we can represent the chain rule using, so another form of the chain rule using what we call Leibniz notation. So another form of the chain rule. So basically using what the dy dx. All right, let me take this problem. Suppose I have y equal x squared plus 1 to the power 10. Okay, and I need to find its derivative. So let's see how we approached it. We introduced the outside function, which is u to the 10. The inside function, which is, we call it g, x squared plus 1. And my derivative, which is, I can call it dy dx or y prime, was this piece, f prime. We computed f prime, and then we multiplied it by, let us see, I called this g before. We multiplied it by g prime. Okay, so it means here we found f prime, but then we evaluated at whatever I put u here. So I'm going to put u in this particular issue because to explain the idea. All right. So it's going to be equal to g prime is nothing more than du dx using Leibniz notation. Am I making sense? G prime is nothing more than du dx when I introduce the u. It's f prime. I'm going to talk a little bit about it. What is f prime? Okay, I'm going to take this piece and rewrite it in the following format. y equal x squared plus 10 could be rewritten as, so this could, we can rewrite as y equal u to the 10, where u is x squared plus 1. Okay, so sometimes we can rewrite this as u to the 10, where u equal x squared plus 1. So because when I put u back here, I'm going to have x squared plus 1. F prime of u, with this notation, f prime of u become nothing more than the dy du. So if I think of y here as a function of u, dy du is 10 u to the 9th. If I think of y as a function of u, the derivative with respect to u, so if I think of this as the variable, is 10 u to the 9th. So another way to write the chain rule is like this: dy dx equal, I take this y and I put a u in here, and I find the dy du. And then I multiply it by the derivative of the inside, which is du dx. And this is another form of the chain rule, which is called using the Leibniz notation. So I'll do another problem, which I use this notation, okay, that you have to be familiar with because a lot of book comes up to use that. So let me do another problem. So suppose I have y equal, whatever, sine of x squared plus 4, okay? And I want to find the derivative using this approach. How do I do it? Okay, the way we do it is that we say u is always what u is. There is the inside function. U is the x squared plus 4. Okay, by putting q to be x squared plus 4, y become sine u. So it means this, we rewrite it as, we break it up. This is y is sine of u, where u is x squared plus 4. And this will become dy dx is somehow easy to memorize. dy du times du dx. Now, dy by itself doesn't make sense. This makes sense, this makes sense. So we cannot sit down and basically simplify. It doesn't make, we cannot do that. Now, what's dy du? At this stage, I'm thinking of y as function of u alone. So dy du is the cosine of u. So here, I'm thinking of y as function of u. Du dx, I'm thinking of u as function of x. This is 2x, which is finally equal to the cosine of x squared plus 4, I go at the end, times 2x. So it's basically the chain rule, but where the notation is what we did actually, but the notation is slightly different, but it's a notation that I definitely want you actually to know. Okay, so we just sine x squared plus 4. The only thing we do is, okay, let y equal x squared plus 4, y equals sine of u. Then when I'm finding the derivative of y with respect to u, basically I'm finding the derivative of the outside function. That's really what I am doing. That's the derivative of the outside. And du dx is the derivative of the inside. But at the end, once I put cosine u, I have to go back to my original value of x. Okay. So that's another notation used to find the derivative when we have a composition. And I want you to be able to be familiar with both of them. Okay. All right. Any questions before I let go? All right. As you know, you have your quiz tomorrow. And then also some of you are not up to date with their MyLab homework. Please get going. Okay. Any questions before I let go? Anyone?
No, thank you. Have a good day.
Okay. Bye-bye, guys. Thanks.